get the speed, right?
Second derivative to get the acceleration, right?
That would be the second derivative. That would be the
Yes.
derivative of the
Yes.
velocity.
Yeah. So it's gonna be 12 minus 6t. That's the acceleration.
All right.
So the question asks you when it achieves its maximum speed.
You set that equals to 0 because the maximum speed, the velocity would be 0, right?
0 maximum speed velocity will be 0. You're right. It will be 0. But you don't know. You want to see this according to acceleration function.
Okay, right.
You want to set this to 0. So it will accelerate until it becomes 0.
Okay.
And then it will slow down. The speed will slow down.
Mm-hmm.
Right? For example, at time 0, a is equal to 12. Okay? If t is 0, a is 12. So it's accelerating. At 1, a is 12 minus 1 times 6 is equal to 6. So it's still accelerating. But when you set to 0 at t equals to 2 seconds, it stopped accelerating. It started to slow down. So when at that time point, it reached the maximum speed. So you understand here?
How did you get 2 seconds?
You set this to 0. Calculate when the acceleration will become 0. You know how to get this function?
Because it's negative 12 divided by
12.
negative 6.
Yeah. 0, so 6t equal to 12, t is equal to 2.
Okay.
At this time point, it stopped accelerating. And the position, simply you can put it back.
So the answer is E?
Is D, 16. So if you put 2 seconds back, x equal to 6 to the square minus 2 to the 3. (24 minus 8), so it's 12.
Okay.
Okay. And number 12.
15.
Oh, 15. Sorry.
You writing in an angle.
What's the angle?
You're writing in an angle.
Yeah.
Right. Try to write straight.
Okay.
Yeah.
Will be easier for you, right? The velocity of a particle moving along the axis is given for t larger than 0. What's the acceleration of the particle when it achieved the maximum displacement in the positive x direction? Okay. So I know maybe you cannot draw. Let's help. So that's t and x. We know we is equal to 32 t because the question asks when it achieves the maximum displacement is when the velocity becomes 0, right? So it will reach the farthest place in the x direction. And when you do it equal to 0, it's going to be t, 2t, you can take out 2, 16 minus t squared. Okay? And then we'll get either t equal to 0 or 4 minus 4. But because it tells us t is time, it will be positive. No? It won't be minus 4. So when t is 4, the velocity will be 0.
Okay, do that step, because I'm not getting how you get t is equal to 0.
So when this is equal to 0, what is t? T will be either, let me put it this way. So if this is 0, okay, either 2t is 0 or 16 minus t squared is 0. Is that right?
Mm-hmm.
So it's t is 0 or t squared is 16. Given t is positive, so t is
So the
4.
square root. Okay, I got it.
You got this?
Yeah.
Okay. So after t is equal to 0, it achieves the maximum displacement. So it's t at this time point,
Mm-hmm.
right? So if you draw it, it's accelerating, accelerating, accelerating. And then start to drop. Okay. So at time is equal to 4, the velocity becomes 0. So at this time point, what's the velocity? Oh, it's asking the acceleration of the particle at this time point. So if you take the derivative of the velocity, it will be the acceleration, right?
6t squared.
6
Right.
t squared, yeah,
Right.
exactly.
And then you plug the
Yeah, the
4.
4. So it's minus 64. So it's going to be 8.
Okay.
So you don't have any problem.
No.
Okay.
We can keep going.
The next question asking you, it gives you a graph. 4, there's 2, there is minus 2. Okay. One line here. Here's 3. Six. That's the graph. And it tells you at time 1, time velocity velocity is 2. Okay, so what's the position? So essentially it's asking you from time 1 to time 6. How long was the distance it moved? Right? That's the question. And we can get the actually there are 2 ways to calculate this. Here the speed, what's the speed here? It's minus 2.
Okay.
That's the velocity, right? The velocity is minus 2 here, and the velocity here is 2. So the average velocity here is going to be 0.
Because you did it from 1
seconds to 3 seconds.
1 second.
Because you need to separate into different region because it has different acceleration here and here. No, before 3 seconds and after 3 seconds. So we need first calculate from 1 second to 3 seconds.
Okay.
Okay. And in this region, because the acceleration is constant, so you can take the initial speed and the final speed, take the average. That's going to be the average speed during this time region. So you understand here? Or you want to calculate it in the regular way?
What is the most simplest way?
This one is simple.
Okay, so now what do we explain it again?
So you know here the initial speed.